Here's the Module 11 Part 4 notes. This is page 2. So we are just going to practice this a couple of times. This is a great time for you to hit pause or wait till after the first example. So you see this again, then hit pause, try a couple of these, and then come back to check. So we want the z-score so that the area under the normal curve to the right is 0.15. So we're going to start with our normal curve. Again, we know that 50% lies above the mean. I get 1 standard deviation above. 16% lies above that. So my 15%, we want 15% to the right, somewhere in here. Excuse me. Okay. Excuse me again, sorry. So there's my step 1 in curve. My normal curve is drawn. I've shaded to the right. It's important to get that shading to the right in there because remember that Excel works from the left. And so when I plug this in, I'm actually looking for that z-score where the area below is 0.85. Okay, this is a standardized normal distribution, so I'm going to use norm.s.inverse, input my probability, which is 0.85. I get a z-score of 1.036433. We spent a lot of time talking about probabilities that cannot be above 1. Keep in mind now this is a z-score, so it can. So I've got a z-score here of 1.04. Example 4, I want the z-score so that the area under the normal curve to the right is 0.95. So somewhere in here, this area is 0.95, which means this area over here, the one that Excel can calculate for me, is 1 minus 0.95, so 0.05. So I'm going to find my z-score with norm.s.inverse. Again, I need the left-hand probability, 0.05. I get a z-score of negative 1.64485. We're rounding again the z-scores to 2 places. The value after is a 4, so we do not change that last digit, negative 1.64. Example 5 is a little different. We want the z-score that separates the middle 50% of the distribution. So sometimes that's important. It's important to say, hey, here's where I think my mean is. How much? Ooh, that's interesting. Can I trap between there? So what I'm looking for here, and again, not too terribly worried about what it looks like, I want the middle 80%. That means I have got 20% left over, and that has to be split evenly between the two ends. So 10% here, 10% here. So when I find this z-score, I got norm.s.inverse of 0.1. After rounding, this gives me a z-score of negative 1.28. And to find this z-score, norm.s.inverse of 0.9, because I need 0.1 to the right. And when I round that two places, I get 1.28. This should not be a surprise. Remember that our z distribution, or sorry, our normal distribution, and in this case our standardized normal distribution, is symmetric. So if I'm chunking out 80% in the middle, that means I've got 10% on each side. Those z-scores should be opposites of each other.